All right, welcome to Geometry Basics 2. This is where we're going to start to speak the language of geometry. It's something we just have to get through. It's not the most exciting lesson in the universe, but we're just going to try our best and see where we end up here. Try to get through it really quickly. So we're starting to talk about points, lines, planes, segments, and rays. Those are some really key ingredients in our drawings. And so we'll just start with a point. A point is just what you're doing to indicate a location. Saying, hey, I'm talking about this area right here. Okay? And it has no size. Now, of course, when you're drawing a point, like, oh, hey, look, there's my point. We give it a letter. I'm just going to call it letter A. It doesn't really matter what letter you call it. It has size when you draw it, of course. But in reality, however sharp your pencil is, you could make that point as small as you wanted. Technically, it doesn't actually have a size. It's just something that we draw so we can see it. So that's kind of a weird concept, but that's the reality of it. When you get to lines, a line is when most people think of it as connecting the points, but really it's just a straight path in two opposite directions. Okay, so let me move that up there. And just like a point has no size, a line has no thickness. So again, you think about how a point is really just there to mark a very specific spot. If we put a point on a coordinate back in Algebra 1, you put it on 6,3. It doesn't extend to 6.01. It doesn't even extend to 6.001. It's exactly at 6, at that exact location. Same thing with a line. It doesn't have any thickness. It doesn't carry on up or down. It just sort of, I just sort of have to draw it, and you pretty much already know from algebra anyway, if we're being honest. Now, the other catch about a line is a line has infinitely many points. So this is where sometimes it helps to actually draw it out. So here's my line. Whenever we're drawing a line in geometry, make sure you're doing arrows, because as that first piece of the definition says, it is a straight path in two opposite directions. Now, when we are naming a line, we find a couple of points that are on the line. So this time I'll use B and C just because I can. And when we name it, we're going to name the line BC. Now there's a little catch here with lines. Everybody loves it. With lines, you can actually go the other direction if you want, and you could call it CB. Because, again, it's going in opposite directions. It's going in both directions. Do you want to go from B to C? Do you want to go from C to B? What do you want to do? And in reality, like that last point says, we actually could put points in here forever. Hey, there's a point there. There's a point there. There's a point there. We could do this forever if we wanted to. We're not going to, but you get the idea. Now, sometimes you will see a little, lowercase cursive letter. We're just going to use a little cursive L here next to a line. What that means is they're giving the line a different name. So instead of having to use the points to do it, you're just saying, hey, we're going to call this line L. So in a way, that's kind of a better thing. That's a benefit. It's a shorter way of doing it. You don't have to use the arrow symbols on top. You just say, hey, this is line L. It's a great way to do it if it's there. If they don't label it that way, you're going to have to use 2 points instead. All right, let's get to a plane. Now, when I think of a plane, think of a piece of paper. Like when you're drawing on a piece of paper, that is sort of your plane. Think of a never-ending piece of paper. That's sort of what's going on here. So a plane is just a flat surface. And again, that flat surface, the book says it extends without end. So it's a flat surface. I'll put a comma in between. and it extends without end. I don't know if there's a better way of saying that or not. Country song about that, but, you know, a love without end. Okay, whatever. That's old time. That's way before you were born. But anyway, think of it as a never-ending piece of paper. Now, this plane does not technically have any thickness. Now, this is where all the sarcastic people are going to say, well, my paper's thick. It's about this thick, and, you know, it's really tiny. Yes, technically your paper does. I'm just thinking of the visual of what a plane really means. Technically in a plane, there is no thickness. A piece of paper is just sort of our way of visualizing it. Now, you can put infinitely many lines on this plane. You could draw lines on the plane forever. Now, when we draw a plane, when we're actually making an image of a plane, you know, I know you're thinking of that sheet of paper analogy. Usually, we sort of draw it with some perspective. So, like, what if you were looking at a paper from the side? It would look almost kind of like a parallelogram, right? Now, this piece of paper might have a few points on it. You know, it might have let's go back to these other letters. Might have point A. Might have point B. You know, you got C, you've got D. Maybe we'll actually make a line out of C and D. Maybe we'll say here, we got C, we got D. We're going to make a line out of that. You could actually do, like it says in the definition, infinitely many lines could be placed on this plane. I could just keep drawing lines forever, and it would never run out of room because it extends forever. Now, this is where things get kind of weird. When you name a point, you use one letter. When you name a line, you use two letters. So I guess it sort of makes sense. When you name a plane, use three letters. Find 3 points that are on the plane, and that's how you give it a name. Now, this is where it gets tricky. What if there are more than 3 points on the plane? Well, use 3 anyway. We designate a plane using 3 letters, which means no matter how many letters are actually on the plane, only use 3. Okay? That's going to be a question someday. Be ready for it. All right. So now what would happen if you only wanted a little piece of a line? So instead of the whole line, you just want a segment. That's what we're going to do. It's a part of a line. So basically, you're going to take 2 points, and you're going to say, I don't want the entire line. I just want the line from here to here. So that's what we're going to do. You're going to take 2 points, and then any point in between the 2 points you chose also counts. So that's how it's going to look. Now, if we look at our visual from earlier, if we look at our line BC, we drew a line, it went from B to C. That's what's happening here. We're just going to take only the part that went from B to C. So instead of drawing the entire line and drawing the arrows, we're only going to go from B to C. Now, when we are naming it, we don't have to put arrows over the letters because we didn't want to extend it forever. My son was doing an activity in 2nd grade. He said, it said, what's your favorite number? And he decided he wanted to be a smart aleck kid, so he put infinity. Goes on forever. Lines do that. Segments don't, so we don't draw arrows in a segment. So when we're naming it, you could name it either segment BC or segment CB, depending on your mood. All right, last but not least, we have array. Now, this is the one that kids get wrong more often, and the reason is because they don't realize that array has to have a specific order, because array only takes one end of a line. So basically, it starts at one endpoint, but then it continues all the way along the line. So it's one endpoint and all points after it on the line. So the reason kids get arrays wrong. So let's look at that earlier example with BC, maybe we'll just change the letters around. Maybe we'll just say this one is going to be YZ. So I'm going to put a Y here. I'm going to put a Z here. So let's say we start at Y, and then we go, instead of going to Z, we're going to go through Z. Okay, so instead of going to the point Z and stopping, we're going to go all the way through. So we got point Y, we got point Z, and it extends through. This is where kids get rays wrong. The name has to start from the beginning and then go out in the direction of the second point. So this ray, and by the way, the symbol is you just draw an arrow pointing in one direction because that's what a ray does. So it doesn't actually extend forever in both directions, only one direction. You have to name it YZ. You don't have a choice. You don't get to name it ZY. That would actually be marked wrong. So I just want to warn you about that. All right. Now, a postulate. Now we're getting into some of this nuts and bolts geometry business here. A postulate, a teacher one time explained it to me as a duh statement, as in something that once you look at, you can pretty much understand right away. We'll deal with postulates and theorems, but that's another conversation entirely. Postulate number one. If you have 2 points, there's only one line that you can make that connects the two. So, I'm going to put my random points here. We'll just go back. Let's do R and S. There's only one line that you can make that goes through these. It would be this line right here. Now, some people would say, well, I could do other ones. Your points are too big. Well, remember, my points are only big because I had to draw them that way. In reality, they don't actually have any size. So there's only one line that you can do it. Now, if 2 lines intersect, if they do, I'm not saying they do, but if they do, they will intersect in exactly 1 point. So, you got your line over here, you got your line over here. Now, the Algebra 1 kids, they're really, really good at Algebra 1. This is where they're like, well, what about the ones that are on top of each other? Well, I'm not talking about coinciding lines. I'm not talking about when you graph the same thing twice. I'm talking about distinct lines, as in if 2 different lines intersect, then they'll intersect in exactly 1 point. And then you also get this... you also get the kid who's like, well, what about if they're parallel? It's like, okay, again, you need to make sure you're being careful about how you read it. If they do, they don't always do, but if they do, it's at 1 point. Now, this third visual, what would happen if you had a plane? So this is sort of, think of it like that piece of paper discussion. What would happen if you had a plane intersecting with another plane? So I don't know. Sometimes you see examples like this where people will do it with cardboard. They'll take like 2 pieces of cardboard and they'll cut a thing out of the middle so that they can go in between. And it's kind of an interesting little visual. So if you just had a plane intersecting with another plane, where would they cross? Well, they would actually intersect in exactly 1 line. Now, when I do this drawing right here, and I'm kind of explaining, hey, these 2 are intersecting, and they sort of meet in the middle right here. Some people would say, well, that's a segment. Well, yes, in my drawing, it's a segment, but remember, planes go on forever. So technically, even though I'm drawing it and it looks like a segment, in reality, it's a line, because both of these drawings, both of these planes, I draw them as just a little sheet of paper, but in reality, they extend forever. All right. And last but not least, if I give you 3 non-collinear points, so basically I'm just going to make a point here, point here, point here. Well, there's not one line that you can use to connect them, but there is 1 plane that they'll all be on. So the very last thing you're going to fill in here, that was awful. I apologize. That was just really bad, but we'll get over it. Through any 3 non-collinear points, there is exactly 1 plane. And remember, when we name planes, we use 3 letters. So let's say we had point D, point E, and point F. Then you would officially name this plane. If somebody asked you to do it, you would name it Plane DEF. All right, I hope this helps you get through the day. Have a good one, and I'll see you another time.